These are real fast.
What's up?
These are real fast.
Alright, we left off on the back last Friday where we were trying to prove that a figure was a parallelogram or not. Right? So on problems like this, yes, up here. On problems like this, okay, where we are given vertices of a potential parallelogram, we have two ways to determine whether it is a parallelogram or not. The first way we went through together on Friday. We said we want to find the slope of all four sides and see if opposite sides have the same slope. If opposite sides have the same slope, then it is a parallelogram. We determined that this figure was a parallelogram because both AB and CD had slopes of -1/5, and both AD and BC had slopes of 3/1. So AD and BC were opposite sides, and AB and CD were opposite sides. The second way is to see if opposite sides have the same length. To do that, we're using the distance formula. Okay? So we want to see if opposite sides. So opposite sides would be AB and CD, and then also AD and BC. And I think we started this one. Did we start this one? I think we did. We found AB and CD. Right? I think using the distance formula, we got the square root of 26 for both of those. Okay. Then for AD and BC, we're going to do the same thing. Using the distance formula, we want to find the length of AD. So if I label A, x1, y1, and D, x2, y2, I can plug those values into my distance formula. So for AD, and remember our distance formula, because we're more accustomed to writing it as x2 minus x1 squared plus y2 minus y1 squared. Okay, but both of these are the same thing. So for AD, my distance, or my length, would be x2 minus x1 plus y2 minus y1 squared. And we're just doing the arithmetic. So -3 minus -2 would be -3 plus 2. So that would be -1 squared. Plus 0 minus 3 would be -3 squared. And we get -1 squared. Remember, anytime we're squaring a negative value, that's going to be positive. So -1 squared is +1. -3 squared is going to be +9. So we end up with AD is the square root of 10. For BC then, we want to do the same thing. So I can relabel my coordinates for B and C, x1, y1, x2, y2. So x2 minus x1 is going to be 2 minus 3. And y2 minus y1, -1 minus 2. So 2 minus 3 is -1 squared plus -1 minus 2 is -3 squared. So -1 squared is 1, squared is 9. We end up with the same thing, square root of 10. All right. So, by going through that process, okay, we found that both AB and CD had a length of the square root of 26. And we found that AB and BC both had a length of the square root of 10. So since opposite sides are congruent, that proves that this figure is a parallelogram. Right? So we can either show that opposite sides have the same slope or opposite sides have the same length. Those are our two big ways to prove that something is a parallelogram. Now there is actually a third way that just kind of combines these two, and it's listed down here. It says if we pick out one pair of opposite sides, if I can show that that one pair of opposite sides is both congruent and parallel. Okay, so if I picked out one pair of sides, say AB and BC, and I found the slopes, said, well, that pair of sides is parallel. And then I took that same pair of sides and found the length. That would be a third method to prove that the figure is a parallelogram. Okay, if one pair of sides is both congruent and parallel, both has the same length and is parallel. Okay? Questions? Right? There is one more thing I should mention. We've talked about this idea already, but the way that something is named. Okay, so in this example, this quadrilateral was called ABCD. Just in the way that it's named, that tells me what the sides are. Bless you. Okay, so since it's named ABCD, that tells me the vertices around the edge are ABCD. So the sides would be AB, then BC, then CD, then DA or AD. And without sketching it out, I know that AB and CD would be opposite sides. And then I know BC and DA would be opposite sides. Okay? Just from how the figure is named. Okay? Because if we're going around ABCD, AB and CD would be opposites, and then also BC and AD or DA would be opposite sides. So those would be the pairs of sides that I would be finding the slopes of or finding the lengths of. Okay. Questions? All right, then you guys try a couple down here. Okay, so for number 1, we're given 4 vertices, and it says use slope to determine whether or not this is a parallelogram. So, again, it gives you a graph, so you can graph it, but you don't have to, okay, because the work that you're going to show is finding the slope. Okay, so you're going to find the slope of AB, BC, CD, and DA, and see if opposite sides have the same slope. Then for number 2, you're going to find the length of each side. Right? So you're going to find the length of RS, ST, TU, and UR, and see if opposite sides have the same length. Okay, so we're going to spend a little bit of time for you guys to practice these 2 here. Okay? Have at it. What's up? So for the first one, I want you to do it like example 1 with the slope, and then for the second one, like example 2 with the distance formula. Yeah, so for the first one, the slope, second No, you need to find the slope of all 4 sides. So there is a limited amount of room on your paper. So if you need an extra sheet of paper to do your work on, that's perfectly fine. Alright, let's take a look at these two problems real quick here. So for number one, if I find all four slopes, I have all four sides, we end up with the slopes of AB and CD are the same. We get 3 over 1. I think one of them you may get negative 3 over negative 1, but remember, negative over a negative is a positive. And then for the slopes of BC and AD, we get 0. So those are parallel. So this is a parallelogram because opposite sides are parallel. For the second one, they ask us to use the distance formula to find the length of all four sides. And we get RS is 4, ST is the square root of 10, TU is the square root of 26, and UR is 4. So we can see that opposite sides do not have the same length in this case. Therefore, it is not a parallelogram. For UR, maybe I might have, let me see, so that would be 2 squared, 2 squared, oh yeah, you're right, it would be the square root of 8. Yep. There we go. So UR is the square root of 8, not 4. But that's still, we can see that opposite sides do not have the same length. So this is not a parallelogram. Now, if you graph these 4 points, it's pretty obvious that this figure is not a parallelogram, right? But just saying it doesn't look like a parallelogram is not a legitimate answer. Okay, you got to prove to me that it's not a parallelogram. So in these types of questions, it's going to tell you how to prove that, either using slope or using distance to prove that it's not it is or is not a parallelogram. Okay. Any questions on that stuff? All right, then I want to talk about the Chapter 5 test from last week real quick. Okay? It didn't go real well. So let me pull something up here. What's that?
Did I take that test?
I believe so. I think everybody in here took it. Oh yeah, that's the one that you did well on. Yeah. All right, let me put this up here. Alright, so on the Chapter 5 test, there were some trickier questions, but there were enough that were pretty straightforward that, I mean, should have at least been able to pass the test, right? So a lot of people missed the pretty straightforward questions. So on Edge Elastic, I put together I called it Chapter 5 Test Redemption. Right? If you were unhappy with your Chapter 5 test grade, you can do the Chapter 5 Test Redemption on here to raise your test score by a letter grade. Right? So if you got a C, you can raise it to a B. If you got an F, you can raise it to a D. Right? Now, I'm going to go through a couple of questions from the actual test. Right? And then you guys can complete the Chapter 5 test redemption if you want to. It's totally optional. Right? There's no penalty if you don't do it. Right? But you can raise your test grade by a letter grade if you do it. Now, I do want to see work. Right? So if you do choose to do the Chapter 5 test redemption, you got to turn in some work too. Right? Like on paper. You got to show me some work. So a couple of the questions on here that I thought should have been pretty straightforward were things like this, like which angle has the greatest measure. So in this example, we're given the side lengths, 5, 7, and 9. So if we're looking for the angle that has the greatest measure, that's going to be the angle that is opposite of the longest side. So in this problem, angle B would have the greatest measure because it's opposite the longest side. Remember we talked about, like, that's like a hinge, like if you're opening your hands, if your hands are open just a little bit, your fingertips are pretty close together. If you open your hands a lot, fingertips are much farther apart, right? Bigger angle, bigger distance on the opposite side. So something like this, angle B is the greatest measure, right?
Isn't that question
There's a similar one. It's a different triangle, but it's a really similar question. Yeah. And then something like this. Name the longest side. So if we're given the angles, it's the same idea. We want to say, well, the longest side is going to be opposite the largest angle. Because of this same idea. So the largest angle is here. Angle E. So the side opposite that is going to be DF. So DF is the longest side because angle E is the largest angle. Right. Then there were a couple of questions where, this was another very commonly missed one. Which of the following sets of numbers can be the lengths of the sides of a triangle? Okay. Our test here was to add the two smaller sides together and see if that sum was larger than the third side. Okay, so we want to say, well, is 1 plus 2 bigger than 3? Is 5 plus 5 bigger than 10? Okay. No, 5 plus 5 equals 10. 1 plus 2 equals 3. This first one is the only one where 4 plus 9 is bigger than 12. So that would be 13. So 13 is bigger than 12. So the only one of these possibilities that can be the lengths of the sides of a triangle would be A. Right? Now, a couple others that I was surprised that were really commonly missed. This was one, okay, where it's just, this one was just a really wordy way of saying which angle in the triangle is the largest. Okay, so in something like this, we need to draw a picture. So Lindsay's got her garden, her triangular backyard, and it says the backyard is bordered by the back of the house that's 50 feet long. So we can say here's the back of the house, and then fence A. So here's fence A, 27 feet long, and then fence B is 35 feet long. So I've got a triangle with sides of 50, 27, and 35. And then we just want to figure out which of these corners has the largest angle measure. Okay? Well, just like what we've talked about, the biggest angle is opposite the longest side. So the longest side is 50. Therefore, the largest angle is opposite 50. It's the corner between A and B. Right, so whenever we don't have a picture, draw a picture. Right? The other kind of straightforward ones were ones like this, right, where we had to list either the angles or the sides in order. In this case, from smallest to largest. I don't know if some people got sloppy and didn't read the whole question and put them in order from largest to smallest, or what happened on questions like this. But if we want to go smallest to largest, with the smallest angle is going to be opposite the smallest side. So the smallest side is 1.2. The angle opposite that is I. So angle I is going to be the smallest. Then the next smallest side is 2. The side opposite that is H. So that'll be the middle angle. And then the largest angle will be opposite the longest side. Alright, so does everybody understand what we mean by opposite? We okay with that? Alright, so the final one kind of wanted to take a look at was just this one, where if we were given the angles, listing the sides in order. So again, we're going smallest to largest. So I want to find the smallest angle. So here's the smallest angle. The side opposite that is PQ. So PQ is my smallest side. Then 55 degrees is my next smallest angle. That means PR is my middle side. And then finally, my largest angle is 80. The side opposite would be QR. That would be the longest side. Okay? So, again, on Edge Elastic, there is an optional Chapter 5 test redemption that you can complete to raise your Chapter 5 test grade a letter grade.
Wait, what?
It's 10 questions. That's it. 10 questions. But remember, I will need to see work. Okay? I will need to see work. So if you do decide to complete that, you need to turn in a piece of paper with work. Yeah. So that you need to get these questions correct for it to raise your test score. Okay? Now, also, there is just a normal weekly assignment on Edge Elastic, okay, due Friday. The test redemption is also due Friday if you decide to complete that, all right?